Object-Oriented Programming Design Principles. We are going to cover three topics here: what is and why design principles. And we'll cover design principles identified by industry. I will start with the S.O.L.I.D design principles, and then we are going to look into other design principles for writing Java programs in object-oriented fashion. What and why design principles? Design principles represent a set of guidelines that will help us to avoid having bad design. This is according to Robert Martin. Characteristics of bad design: rigidity, fragility, and non-usability, sometimes called immobility. Rigidity means whenever you make a change, it affects too many parts of the system. So this is what we call spaghetti code. Fragility: when you make a change, unexpected parts of the system break and you don't even know it. So it's very fragile. Immobility or non-usability is hard to reuse the code because it cannot be. It is very tightly coupled with other parts of the application. What about the characteristics of good design? Obviously, the opposite sides of the bad design. It should be clean and modular, and it should be highly cohesive, and it should be loosely coupled. The benefits of design principles are benefits of applying design principles to your application. Includes extensibility, testability, code reusability, and runtime changeability. Extensibility means new features can be added without breaking other parts of the system. Testability: of course, testing is very important, so you should write your code so that it can be testable. Code reusability: software piece or component should be reusable in other part of the application or in other applications. Runtime changeability, sometimes we call it flexibility. The behavior of a software component should be able to be changed during runtime without modifying existing code. So we are going to look into design principles that will result in these benefits. So let's move on to S.O.L.I.D design principles. S.O.L.I.D design principles include these five: and single responsibility principle, open-close design principle, Liskov substitution principle (LSP), and interface segregation principle, and dependency inversion principle. So let's look into each of these design principles in detail. Single responsibility principle, the motivation is that if you put more than one functionality in your class or method or in a package, it introduces coupling between these functionality. In other words, there should not be more than one reason for a class or method or package to change, and the class should always handle single functionality. Basically, you do not want to mix responsibilities or concerns or functionality into a single class. And benefit, of course, result in less coupling and higher changeability. Okay, so let's do the lab. Exercise 1, single responsibility. So I assume you have downloaded the zip file, and you unzip the zip file, and there are sample applications on the samples Maven directory. So you basically import those sample applications. Those are Maven projects, so you should actually import as Maven project. Basically, I have actually Java working set. You say right click and import, and make sure you are importing as a Maven project. Okay, so you want to expand Maven and existing Maven project and click next, and you want to specify the location, and I have already imported those sample applications. Okay, so let's take a look at the single responsibility before and after. So before means this is the code that does not have this single responsibility principle applied, and after is the one that has this single responsibility design principle applied. So you can actually compare these two code. So let's take a look at the before. So in this case we have a person class, and person class has name, email address, and email content and things like that. But there is also send mail method here. Send mail. By the way, whenever you see bad, that means this is the bad code, meaning it needs to be refactored to apply this design principle, in this case single responsibility. So send mail definitely is not part of the person class, so this method should be refactored so that it is in the different class. So we have a client, basically we create a person class, you set the name and email address, that's fine. It's okay for a person class to have a name property and email address property, but send email, I mean, this definitely should not be part of the person class. Okay? Person class should actually have attributes and methods that are relevant to a person, but it should not have send mail method, which is definitely different from the different responsibility. Okay, so what we have done is we are going to separate out the send mail. So in this case we have if you take a look at the person, it just have a name and email, and also we created email class as well. So email class capture basically email related information, in this case email content, and then we have an email sender class. So basically email sender is responsible for sending email, so it has a send mail method. And so in this case client, we create a person class, we can set the name, and we can set the we create an email, and then we can set the email content, and then we are going to have an email sender object, and we send the email. Okay, so we separate out the sending email and also actually the email as a separate classes. So each of these classes, email sending, email sender, and person, each of those classes now have the single responsibility. Okay. All right, so I'm going to stop right here, and I am going to ask you guys to convert this before to look like after. I don't expect you to be exactly like an after, but the exercise is to change before code as close as possible to the after class. Okay, after project. So I'll give you maybe 10 minutes to do this exercise.